Хорошо, значит, в принципе, то, о чем я буду говорить сегодня, связано с тематикой предыдущего выступления, которое было уже довольно долгое время назад. Некоторые, возможно, кто из вас был здесь в прошлый раз, когда я был? Двое всего. То есть для остальных это будет вполне новая тема, я не буду стесняться повторять. Это хорошо. В принципе, по философии того, что я буду делать, это немножко будет отличаться от предыдущего выступления, наверное, в следующем плане. То есть в прошлый раз я говорил значит, о вещах по большинству своему исследовательских. То есть это были относительно новые темы, относительно недавние результаты и такого рода вещи. В этот раз у нас будет более такая обзорная тематика и первой, и второй лекции. То есть у нас тут две пары примерно по 1,5 часа, если я правильно представляю себе это. Значит, первая тематика это у нас будет безопасность веб-приложений. Вот, примерный план, значит, обозначен у нас в данном случае на слайде. То есть мы начнем с довольно-таки базовых простых вещей, таких как SQL injection и cross-site scripting. То есть это базовых уязвимостей, которые существуют в веб-приложениях на стороне сервера. Это будет начало сегодняшней дискуссии. После этого, где-то после половины лекции, после середины лекции, мы продолжим обсуждать темы, которые связаны больше с браузерами. То есть, какие механизмы существуют сегодняшних браузеров, как они, так сказать, защищены от потенциальных уязвимостей. И вот примерно тематика, которую мы будем обсуждать. То есть, same origin policy, cross-domain requests и вещи, связанные с потенциальными способами защиты, таких как cross-site scripting filters, такого рода вещи. Для контраста приведу несколько примеров вещей, которые я не буду обсуждать сегодня, но тех вещей, которые, в принципе, возможно, если я вернусь сюда еще, с которых мы, может быть, и продолжим. То есть вещи такие, как статический анализ кода в браузере на клиенте. Одна тематика, о которой можно говорить. Вторая тематика — это динамический анализ такого же рода, то есть какие механизмы в браузере, в JavaScript engine, такого рода вещах существуют для того, чтобы дать определенную степень защиты. И третий вариант — это то же самое, то есть анализ либо статический, либо динамический, в данном случае на сервере. То есть обычно, когда я преподаю это в плане курса, который продолжается, ну, скажем, месяца 3, обычно обсуждаются, в общем, это вот первая часть слева, это, пожалуй, 1 лекция, может быть, 1,5, и то, что вот справа, это еще 3-4 лекции. То есть примерно я пытаюсь дать вам примерно как бы диапазон того, что теоретически можно в данном случае обсуждать, но на практике мы остановимся только вот на том, что обозначено с левой стороны. Окей, значит, что у нас следующим образом? Следующим образом у нас как бы введение, собственно, в тематику. Но должен вам сказать, что в таких ситуациях как бы у меня некоторая дилемма. То есть с одной стороны, я могу как бы это обсуждать, наверное, по-русски, теоретически тоже, но с другой стороны, у меня как бы не хватает терминов. Я не знаю, как некоторые вещи переводить, и, в общем, постоянно я на этом спотыкаюсь. Поэтому я этого делать не буду. Вот, я, в общем, наверное, закончу с философским таким введением по-русски. Вот, и продолжу по-английски. Если у вас есть вопросы, вы можете их задавать на, собственно, любом вам доступном языке, включая, я уже не знаю, древнеарамейский. Вот, и мы с ним как-нибудь справимся, и богу, это не будет так сложно. После этого в конце можем, как бы, значит, у нас будет небольшое обсуждение, в зависимости от того, сколько у нас времени останется. Может быть, останется на самом деле не так много времени, потому что информации довольно много. Скорее всего, я буду пропускать немножко некоторые слайды, потому что, ну, хотелось бы закончить вовремя, поскольку мы и так уже начали довольно поздно. Alright, so let's get started over here. So we have our client, which is the browser on the left-hand side. We have the server, which is some sort of a program on the web, somewhere on a web server, you know, responding to requests. And basically, this is the interaction, right? So we have a request, an HTTP request, and we have a response coming back. This is the basic interaction that happens all over the web. Every time you go to a site, there is a request, comes back, there is a response. This is sort of the very basics. Okay. Now, if you look at vulnerability statistics, so here's one, source of these vulnerability statistics produced by the MITRE Corporation over here. But, what's interesting is how these things change over time. So the red line is web vulnerabilities over here, and the blue line is things like buffer overflows and maybe, I don't know, dangling pointer references and things like that. So these are web vulnerabilities that exist primarily in managed code, code written in Java and maybe PHP and maybe C#. And these buffer overruns are written in C and C++, code written in C and C++. So we see a big change that happens around year 2005 or so. So before that, we have buffer overruns being very popular in this area. And then after that, basically after 2005 and up until now, we have web application vulnerabilities dominating the landscape. So this is an important change, and this is important for several reasons. I mean, one reason is because, well, really this is why we want to focus on these kinds of vulnerabilities, to avoid them in the future and to come up with ways to prevent them and detect them. But another reason is to think about why that is the case. So any guesses as to why we have this change, buffer overruns going down over here and these guys going up? Any thoughts? Догадки, соображения?
Во-первых, мы больше стали использовать инструменты кода. Во-вторых, развиваются всякие средства для диагностики бафферов.
Какого рода средства?
Статического анализа, динамического. Можно сгонять программу просто.
Это все правильные причины. Что еще? Какие еще есть причины? Какие еще, так сказать, есть соображения? Все, что было пока сказано, это правильно. Что еще? Okay. То есть миграция в этом направлении. Что еще? Слабые разработчики мигрируют в это русло, скажем так, тоже. Правильно. Что еще? Client-side, да, JavaScript, безусловно, проще анализировать, и это, возможно, упрощает работу атакера, да, возможно, да, теоретически правда, да. Ну, то есть потому что вот, в частности, есть простой интерфейс, который доступен извне, да? Это правда, да. Еще одна причина, которая может быть не так очевидна, это то, что примерно вот в это время, вот здесь вот где-то, да, с 2003 по 2005-2006 год, операционные системы вводят всякие интересные новшества, то есть технология ASLR, например, и DPNX, которая, возможно, вам известна. То есть первое — это рандомизация, heap randomization, что это такое? Это у нас рандомизация чего? Кучу, точно, спасибо. Первое. Второе — это DPNX, это Data Execution Prevention. Это технология, которая позволяет маркировать определенные страницы памяти, чтобы не разрешать там исполнение, то есть этих конкретных страниц. И комбинация этих техник, на самом деле, в общем, колоссально помогает с точки зрения защиты. Довольно простые вещи, практически ничего не стоят во время исполнения, но при этом довольно эффективно. All right, so coming back to this, all right, so what do we have? So we have a chart that shows sort of the relative prevalence or popularity of different web vulnerabilities out there in the wild. So we have cross-site scripting and SQL injection over here shown in green, and then blue, these guys over here. Basically, generally being most popular. There are other things like cross-site request forgeries, things like that. We're not going to focus on them too much, but this is one view of how you can collect the statistics. But really, here's another report from Sensic, which is a company in this space from 2010. This is what they say, right? So the most common published vulnerabilities on web applications detailed in the report continue to be cross-site scripting and SQL injection, which account for 28% and 20% of all web attacks. And this is what we're going to talk about. This is a relatively basic introduction. We'll talk about cross-site scripting, where that comes from, and SQL injection, where that comes from. So in many ways, these are, cross-site scripting is basically what buffer overruns were maybe 10 years ago. It's by far the most popular thing. It happens quite a lot. It is also quite damaging. We'll talk about why that is the case in a little while. Okay, so let's start with that. SQL injection, cross-site scripting. So here's the beginning. This is kind of an obligatory joke here. I'll give you like 5 seconds to read this if you want. So it tells you like this is the gist of the joke. All right. All right, so here's how it goes. SQL injection. So SQL injection attacks focus on a particular site, not a particular user, a particular website out there. Okay, this is something to keep in mind. So really, at the core of the issue is this issue of untrusted input. There's untrusted, unfiltered input that comes from the outside that might be crafted by the attacker, and that goes over to the application, and that reaches a database of some sort. So the picture looks kind of like this. So let me walk over here. All right, and this is the web application sitting over here in a server of some sort, and there's a database over here in the background. So this is the database, and then there is the user over here. And the user says, and you know, generally speaking, nothing. I mean, everything would be fine. This thing is falling apart. Сейчас, секунду, да, можно. Так лучше? Okay. All right, so imagine this being the attacker. So they send some sort of a specific crafted input that goes into the application. There is some processing happening in the application over here, but eventually some parts of this input make it to the database over here, and that way the attacker gains some control over what happens in the database. That's what's at the core of this issue. And this is just the beginning, as we'll see. And again, this is a specific case of a more general problem of using untrusted input in some sort of a command, and we'll see how the same thing or a similar thing plays out in the case of cross-site scripting. Okay, so here's an example. Let's go with this. So here, suppose you have an application that looks like this. You have some sort of a pizza delivery service you are building, and this allows you to, you know, search for orders going back, you know, 10 months. And generally speaking, you know, if you enter 10, this is the request that would be formed. So this is the URL, and this month becomes a parameter over here. This is normal use. Now, imagine what happens in the backend. So in the backend, there is some sort of an application. Maybe this application is written in Java, and maybe this application has a statement that looks like this. In this case, the SQL query is being constructed using this string concatenation over here, where this is the select part of the query. Here, the name of the current user is being appended into the command, and the last part is this month parameter. Let's focus on this month parameter. This is the part of untrusted input that's very easy to modify. So a normal query would look like this. So the order month is going to be set to 10, and this will give us, you know, the information that we want. Okay? So suppose we do something different. So suppose we actually have a request that looks like that. So when we do URL decoding, which is how, I mean, basically URLs only support a certain string of characters, certain set of characters, these need to be decoded, but when they're decoded, basically it will amount to this. This is the decoded version of this string over here. It equals 0 or 1 equals 1. So when we put it into the query, this is what comes out. So what's the result of this? The entire table will be returned, exactly. So the entire table is returned out of this query, which is designed to be filtered, you know, to only return a selection of month. But this is, again, just the beginning. So let's take this idea further. And this is why, basically, you know, this will return every sort of row in the database, which is obviously bad. Because not only are we going to return rows for this particular user, but because of the precedence of these operators, we'll actually return orders for every single user that we have in the table. All right, so that is already pretty bad, but let's take this further, as I said. So what about this, for instance, right? So since we can have control over the last parameter, we can basically do this. So this part over here, this is where we start controlling the input. This part I'm highlighting over here. So the part that we have here, 0 equals 1, 1 equals 0 rather, this is going to be ignored, but instead what we're going to do is we're going to gain access to this other table, which in this example has, you know, somebody's, I don't know, people's credit card numbers, basically. Okay? So let's take this further. So how about using the semicolon? So in the case of, you know, SQL queries, you can separate multiple commands using a semicolon. And this is how it works, right? So basically what we have is we put a semicolon over here, and then we have this. Right? So drop table is basically removes a table from the database. All right. And there you go. And here's another one. Here's another example. So we use the semicolon trick again. And then we call this. We have the second command, which is insert into admin values, hacker and their password. Right? So this is how they will be able to gain further access to the system by basically creating an account with a known password that they would be able to reuse further. So basically, if things go according to plan, the database is fully owned. There is full control over the database, the data in there, as well as the ability to insert new information to the database and potentially, do something with the rest of the system, like as we'll see in just a couple of slides. So let's see. So what's going on here? Oh, right. So here's another example that shows that this might not be quite as simple as we imagined before. So what if we have these quotation marks around the parameter over here? So this topping parameter is a string instead of a number. So we have the same thing, get parameter topping over here, which is a string, and then we put quotation marks around that. So is that a problem? Well, turns out to be not a very big problem. Why? Because all we do is we basically close the quote, right? And then we can do the same thing we did before, and we also can use this, this thing, because that indicates the beginning of a comment, because the rest of the command will be simply ignored. All right. So this is the effect of that. This is basically what I described, and this is that. Okay. So this is just a series of examples to show you the potential damage and how to orchestrate these attacks. And there is a number of solutions that people have come up with, and so here are some of these solutions listed for SQL injection. And things become a little bit more complicated when it comes to other attacks like cross-site scripting, but let's start with this. Let's kind of look at these solutions, then let's try to think about how effective they actually might be. Okay. So blacklisting. So what's blacklisting? Basically, we are going to disallow certain known bad inputs. Right? We will have some characters we don't like, maybe, and we are going to disallow them, and this is how it might work. So we'll have this function called kill chars, kill characters, that will pass this parameter over here in, and then we'll put the quotation marks as we did before, and the goal of this kill chars function is going to be remove quotation marks and semicolons and double dashes and things of that sort. Well, so is that an easy thing to do? And so here are some, some sort of subjects, for discussion for us, which is, it generally turns out to be very difficult to eliminate all bad characters, right? So what if we miss one character? It's enough to miss a single character for the attacker to devise an attack usually. What about sort of this other issue, which is conflicting with the functionality? What if we decide to remove these quotation marks, single quotes, and then there is a user whose name is O'Brien? That person will be, basically blocked down. They'll be very unhappy, and that's kind of how the story goes. So it turns out that proper blacklisting is difficult because for one thing, it's really difficult to come up with a proper blacklist. It's easy to miss things, and people routinely miss things when they try to do blacklisting. And the other issue, you can be too aggressive when you're doing blacklisting, and then you can block some proper functionality of the application. That's also bad. So an alternative to this is to use whitelisting. And generally speaking, blacklisting is not an approach that is recommended. If you go and talk to architects of major products, the moment you mention blacklisting, their alarm will go off because they know that this is not generally a very a very sensible technique in the long run. So whitelisting is an alternative to this, which is to say that it's the opposite approach. So we have a set of characters that we allow, right? For the months parameter, for instance, we will say that only integers within a given range will be allowed. But if you send your months to 37, then that's probably not a valid month, and it shouldn't be allowed. Something like that. So if invalid input is detected, then we'll disregard it, we'll reject it right away. So the idea is basically this. We'll have these validators over here. So imagine these things over here being input parameters. So there's one parameter, there's another parameter, there's another parameter, and so forth. So this might be the month over here. This might be the, what is it, topping or something like that. Some string over here. And then there will be validators that are set up over here, whose job it is to basically ensure the validity of every parameter by running it against some sort of a set of conditionals or some sort of a whitelist. Okay? So this is actually a reasonably sensible way to set it up. So the moment something, one of those parameters, is outside of the range or outside of the set of characters that's allowed, basically the entire thing will be disregarded, and there will be some sort of a response to the user that says, invalid parameters detected or something like that. Okay, so that's kind of a reasonable way to go. Now, here's a question for you. So this is what generally happens on the server. Can we do this in the browser too? So is it a reasonable thing to do in the browser on the client side?
It's much more user-friendly to make it in the browser.
Okay, much more user-friendly because the response comes back. If the results are invalid, the response comes back right away. Is that what you mean?
What I mean is that if we make validation client-side, we make the validation much faster, and we make it much more intuitive and easier for user to fix the input for a normal user, not for an attacker.
Okay. What else? It doesn't fix anything. Why?
Because the attacker still can use the HTTP request with... I didn't say we do not do validation server-side.
Okay.
We have to do both.
Okay, we have to do both. Any other opinions? Yeah?
Можно оставить только на сервер-сайте, если у нас есть какой-нибудь Аякс, который позволяет нам очень дешево общаться с клиентом.
Но причина, которая была упомянута до этого, при этом, в общем-то, остается. Так или иначе, все эти проверки можно обойти. Okay, so let me summarize this. So the upside is that the interaction is more responsive. That's the good part. The downside is that those checks are not to be trusted because they can be easily removed by the attacker. They can just go into the browser and edit the JavaScript, and that will be thrown out. Or they can go directly using an HTTP request by just crafting an HTTP request. You can use wget, you can use ncat, you can use whatever, they can use whatever they want. There are plenty of tools for that sort of thing. So generally speaking, today in large applications, people actually do both, or at least a little bit of both. You see? All right.
I'm a software developer at the firm, at an enterprise which develops quite large internet-based solutions. That's why I don't only see it. I
Yep.
know it in practice.
Okay. So all right. So both can be used, but client side is not enough. Okay. So that's the thing to remember. All right. So what if? All right. So let's start with I don't know. Let me give you a puzzle of sorts. So what if you have a credit card number that you need to enter? So you have a form, right? So it looks like this. So this is the name. This is the address, and then there's a credit card number over here. So how would you do validation for this? And then the credit card number is used, and then maybe it's put into some database on the back end and so forth. So how would you do this? How would you deal with this? Suppose your goal is to validate the credit card number. How would you do it? Yeah.
Well, actually, we have to do it multi-level. First of all, we have to validate roughly that it is in the valid format.
Yeah.
The groups of the fixed number of by print file separated. We might also check the code of the bank against some well-known list. That's all what comes to my mind.
Okay, so that's roughly right. So basically, there will be a lot of checks that happen on the back end, and finally, there will be probably request to a bank to actually perform that transaction. The bank will have the final word over whether that's a credit card number that's valid, because if they don't have it on record, then, well, it's probably not valid or expired or what have you. But on the client side, you can also do additional validation. Particularly, you know that the format usually is 16 digits, right? 4 groups of 4 digits. And there is also some other stuff that I'm not sure if you know about this, but there are also other internal sort of constraints that actually credit card numbers have. So there has to be a certain, logic to these things. Not every 16-digit number actually is a valid credit card number. There are some internal constraints, and sometimes on the client side, they would compute a certain, there's an algorithm that basically allows you to check basic validity. It's not, it's a necessary but not a sufficient condition, right? So sometimes people would actually do this on the client side too. All right. When it comes to prepare statements, though, there is actually a very easy solution that exists for SQL injection problems. So prepare statements is the name of this approach, and this is how it goes. So let me just give you this example. So instead of constructing a SQL query using string concatenation, as I showed you before, this is one alternative. So and this is Java syntax, but other languages and systems have similar libraries and things like that. So there would be a call to prepare statements where these guys, the user ID and the order month, would be indicated by a question mark. So those would be the parameters. And then you proceed to set the parameters. So the first parameter you set to this current user ID, and the second parameter you get to the integer you get out of this request. And then you call execute query that will actually run this query and get the results. So what is the difference between the old approach that we saw before and this approach? What's the difference in principle? How is it different?
This will ultimately check the validity of the whether it was
No. Why is it not possible?
Because we are setting by variable, but we leave the code text of this query intact.
Well, the text is not entirely intact, but the structure is. You see, the parse tree, if you think about how this command is parsed, I mean, basically what's going to happen is that there would be some sort of a command over here, and then there would be select part, and under that there will be some parameters over here, and then there will be a from part, and then there will be a where part, and so forth. So there will be some sort of a parse tree that the SQL engine is going to generate out of this query. And the point is that the parse tree is pretty much fixed by these prepare statements. There will be no expansion in the parse tree that will happen as a result of those other parameters. The parse tree is pretty much set, and all you can do is change these individual values, these individual parameters that happen to be located over here, and that's it. So the difference is that in the first case, типизация на самом деле здесь не так важна, потому что типизация в языке и типизация на уровне SQL queries — это немножко разные вещи, хотя и связанные, первое. Второе, принцип все-таки немножко другой. Принцип того, что у вас фиксированная фактически команда, за исключением параметров, которые туда вставляются. Но параметры, которые туда вставляются, не приводят к тому, что сама команда меняется. Правильно? То есть команда фиксируется и известна статически. То есть вот можно посмотреть на вот этот вот prepare statement и узнать, какой она является. И это упрощает анализ, это упрощает и ручной анализ, так сказать, и автоматически. Безусловно, то есть существует понятие precompiled SQL statements, которые позволяют вам статически, так сказать, построить evaluation tree, позволяет делать оптимизации и так далее, и так далее, и так далее. То есть, в общем, со всех сторон становится несколько лучше. Okay, so let's see. All right, so here's an example of SQL injection in the real world out there. So this goes back to 2006, about 5 years ago. So Car Systems was a major credit card processing company out there, and then they were put out of business by SQL injection attack. Basically, somebody devised some sort of a very clever, successful SQL injection attack against these guys, and they had a bunch of credit card numbers foolishly stored unencrypted in their database. So basically, they got about 2,600,000 accounts were stolen, and a whole bunch of user identities were revealed. And basically, these guys were sued and had to declare bankruptcy because they couldn't deal with this kind of stuff. В этом случае я не знаю, то есть это в некоторых случаях да, в этом случае я просто не помню. Нет, существуют способы, о которых я в данном случае говорить не буду из-за недостатка времени, которые позволяют вам узнать структуры. Значит, совершенно верно. Часто по типу ошибки, которая выдается, часто по коду ошибки, который выдается, и по такого рода, в общем, как бы это сказать, indirect indicators, то, что называется, можно понять со временем, по крайней мере, ну, то есть вот в результате выполнения большого количества запросов можно понять структуру базы данных. Так? Поняв структуру базы данных, можно это делать все более и более успешно и так далее, и так далее, и так далее. И, в принципе, существует, ну, скажем так, то есть довольно длинные и несколько муторные, я бы сказал, tutorials, которые объясняют, как это делать, в общем, довольно-таки детально. То есть существуют довольно дикие при этом подходы, которые позволяют вам использовать эти вот варианты тестирования с помощью удаленных запросов, чтобы практически бит за битом, в общем, всю базу данных таким образом и перенести. Но понятно, что это подразумевает, что при этом база данных так сидит и не сопротивляется. То есть если вы большое количество такого рода запросов будете создавать, то какой-нибудь firewall или что-то в этом духе явно обеспокоится со временем. Поэтому такого рода схемы, как правило, подозревают некоторый такой абстрактный, сетап, который часто на практике не существует.
Ну, если база недостаточно хорошо настроена с точки зрения безопасности доступа, то там можно через внутренний механизм самой базы зачастую получить знания о ее структуре.
Да. Более того, так сказать, существуют подходы, которые, ну вот скажем, я не помню, по-моему, Oracle позволяет вам делать что-то вроде. Скажем, вы используете тот же самый подход, который я описал до этого, это у вас semicolon, потом что-то в этом духе, или, например, semicolon, и после этого у вас есть что-то такое вроде exec command, и после этого у вас доступ к операционной системе, грубо говоря. Да, должно быть совершенно верно, должны быть правильные permissions, это правда, но как бы можно пытаться использовать все из этих подходов. Если один из них работает, как правило, достаточно, чтобы, так сказать, выяснить побольше информации и, в общем, со временем преуспеть. Ну, это примерно, ну, то есть это как залезать на большую гору. То есть понятно, что не всегда это получается, но можно иногда найти следующий, так сказать, логический шаг, и после этого следующий, и иногда, в общем, приводит к такого рода вещам. Безусловно, не всегда, безусловно, так сказать, это не гарантия, но так или иначе, в общем, это работает сравнительно часто, но при этом у этого есть очень простое решение, в отличие, скажем, от кросс-сайт скрипта, которого такого простого решения не существует. Поэтому, в общем-то, больших оправданий на данный момент иметь приложения, у которых есть SQL injection vulnerability, на данный момент я бы сказал, что нет. Запомните этот вопрос, мы сейчас к нему вернемся. Окей, продолжаем. All right, so let's talk about this. So let's talk about this, and this is going to be useful for the discussion of cross-site scripting, and also it's going to be useful for the discussion of browser security which is coming up later. All right. So there is this notion of a network attacker that exists in traditional network security, and usually your network attacker will be able to sit and examine packets, somebody who can intercept network traffic, Wi-Fi traffic, and so forth. This is different. This notion is of a web attacker. So usually, what how people model this is, the attacker can set up a website. Maybe they can even create SSL certificates for this. We don't really know, we don't really care. But creating SSL certificates is actually pretty easy. And then there's a user, the innocent user goes and visits attacker.com and bad things happen. So why would the user visit attacker.com in the first place, you might be wondering? Well, there's a whole bunch of reasons. And so here are some of these reasons. So there might be a phishing email that's sent to the user that goes and invites them to visit attacker.com. And some enticing content, and then maybe search results will take them to attacker.com. And there's this whole area of search engine hijacking and sort of this black ops optimization and so forth, where these malicious results are being inserted into results that you get from Google, for instance, and so forth. And Google is obviously doing a lot to prevent that from happening, as we'll see, but it's still fairly difficult. Что? Я не знаю, какие-нибудь объявления, так сказать, фармацевтическо-медицинского свойства. Я уже не знаю. Да, какие-то заманки, что ли, да. Malicious ads, то есть, so basically ads that are placed alongside normal content, and then the user clicks on those, and then they get taken to this attacker website, and so forth. But at the same time, it's assumed that the attacker has no direct access to the user's machine. And so whatever attack they want to perform is going to be done remotely, right? By setting up this website, and maybe a few other things along the way. Okay? So this takes us to cross-site scripting. This is a very basic version of cross-site scripting that we'll start with, and then things will get slightly more complicated as we proceed. So suppose we have an application, right? And the application is not very careful about sanitizing its input, just like before. And this application has a piece of code that looks like this. So they're basically just printing back the name of the user. And they're putting some div, tags around that. So this sounds very, sensible, but at the same time, imagine this name of the user being a piece of script, right? So imagine you having a piece of script that looks like this. So this thing will capture the cookie and will send it off to some location. So what is the attack scenario over here? So the attack scenario is roughly like this. Что? Окей. Не очень, конечно, замечательная эта штука, но окей, это чуть-чуть лучше. Okay. So what do we have? We have the attacker website over here, attacker.com, and we have the user. And basically, so let's see. So actually, no. Let's take this back. Suppose we have some sort of a benign application over here. And the setup is that the user has some credentials with that benign application, so it might be something like, well, I don't know, gmail.com. Okay? So the user has a cookie that is associated and lives in their browser that's associated with gmail.com, and that cookie is something they can use for login at least for the next day or so, for instance. The cookie has an expiration date, but it's probably good for a day or two. And the idea is that if the attacker were to capture that cookie, then they'll be able to log in into that user's Gmail account and then send email on their behalf and maybe use that account for phishing and maybe compromise other parts, of that user's kind of ecosystem. So maybe they have some information that relates to their purchases or their credit card number, things of that sort. Okay? So, well, how would they do it? So suppose there is a cross-site scripting vulnerability of this kind on gmail.com. I mean, I don't think there is, but let's use this as an example. So there will be this kind of request-response kind of thing on gmail.com that will basically take the input and then try to print it out. And usually, for a normal user, it will just print out their name. But for an attack scenario, basically what's going to happen is this. So the user will get maybe a piece of phishing email that will contain a link like this, http gmail.com, and then slash, and then maybe some parameter like name equals, and then the rest of this, basically script, and then some script over here, and then script over here. And this obviously has to be URL encoded and so on and so forth, because otherwise it just won't work. But I'm not going to show this because this is just an example. You can deal with URL encoding yourself. So this script is going to be put in this context over here, and then you can have a piece of script that looks like that, which will capture the cookie. So this is a very basic idea, right? So the user is fairly likely to click on this link because it looks like a Gmail link. What do they know what it does? They don't know, especially when this is URL encoded. It all looks the same to them. This information is put into that context, and this might lead to this cookie theft problem. What else can it lead to? What other problems can we create this way? What else can we do sort of in this context?
I suppose redirection of the current page
Okay.
to some other phishing site.
Okay, so how do you do that?
Well, I'm not a JavaScript flutter.
So we can say window.location equals some site. That's how you do redirects. What else can you do?
Если в браузере, в текущем браузере есть какие-то уязвимости, то это можно сразу задействовать.
Это правда, да, это можно, да, безусловно. То есть можно использовать как, так сказать, механизм для атаки по отношению к компьютеру, на котором это исполняется, безусловно. Да, что еще можно сделать? Каким образом? Да, безусловно. То есть можно использовать это. То есть как бы некоторые ограничения в этом плане есть, и в некий момент, наверное, это обнаружится, но теоретически можно, да. Что еще можно делать? Да. Можно перехватить информацию, совершенно верно. Что еще? Вы это исполняете в контексте определенного приложения. В этом приложении есть масса библиотек, масса функциональностей, которые там существуют уже в любом случае и так далее. Что это позволяет вам делать?
Можно сразу какое-нибудь письмецо отправить.
Например, да, можно послать письмо. То есть это все можно, опять же, закодировать в JavaScript. Можно, например, послать письмо, можно удалить существующие письма, можно перекачать их на какой-то другой, я не знаю. Совершенно верно, да, список контактов, который после этого будет использоваться для спама. Да? То все эти возможности существуют, в принципе, вот в этом контексте. Окей, продолжаем. Okay, so here's an example of cross-site scripting in a slightly bigger application, I guess. So here's an example of a piece of code that's written in PHP. This has somewhat crazy syntax, but doesn't really matter. So really, here's what matters. So this basically mixes HTML, roughly speaking, with some code, little snippets of code. And really, the code is sort of over here, this PHP block over here. And then there's also a little bit of code over here. So the part that really matters for us is this background. See? So basically, we get this background variable out of PHP, and this background is computed over here. So this is just a parameter that's provided to the application that's directly injected into the style block in HTML, in CSS, and then the same happens to this color parameter, also directly injected into this style block. So normal use is basically this. This is a normal use case. The color is red and the background is pink, and basically this is what you get. Looks kind of ugly, but this is the functionality that they want. So now imagine you designing something else. So how about you set the background to this string over here? So what will that do? It will close the style block. Yeah? So let's get rid of that. We don't really care. But it will start a new script block over here. And then this is going to write something to the browser, which is this string over here, and this string is just XSS. Just to show that this is possible. Just to show that it's possible to have execution, but obviously you can have other things like what we described before, which is something that captures the cookie, something that executes commands, and so on and so forth. Obviously, if there is no data, if there's no state associated with this application, this is probably not very valuable. But the more data you have associated with this application, the more interesting this becomes for the attacker. Okay. Here's actually an example from some site I was browsing actually just a couple of weeks ago. And so this is, so Harvard has this classics club. So for people who meet every week and talk about, I don't know, literature in Latin and things like that. And so they have this great, forum over there. So you can provide your name, your email address, your website, as well as, some stuff over here. So they say, so at the bottom over here, they say the following. So this is what they say. You may use HTML tags and attributes like ahref, and also, bold and, italic, I guess, and em, emphasize, and then quotes, and then strike and strong. So they really want people to, use these rich text tags to input their content. I'm not quite sure why, but they want to support, this wonderful, I don't know, discussion forum, and that's why they enable that. So is this a good idea? What do you think?
Depends on the implementation.
Okay. So what do you mean?
Ну, я хочу сказать, что если делать нормальный синтаксический разбор и валидацию, то почему нет? Но это довольно трудоемко.
Да, насколько в общем реально, насколько в общем просто сделать нормальный статический разбор и валидацию.
А средник не очень-то просто.
Регулярное выражение, которое проверяет на валидность email, персональную страницу в частном тексте.
Совершенно верно, да. То есть, в общем, более того, можно начать вот с этого списка, предположим, да, они поддерживают italics. То есть вот у вас есть. То есть это вот то, что они ожидают. Откуда может появиться скрипт в данной ситуации? Можно. Ну, давайте начнем с этого. Значит, с точки зрения вот этого у нас есть, масса возможностей, честно говоря. Можем сделать что-нибудь в этом духе. Например, можно сделать onClick equals JavaScript. Так? Или даже не onClick, поскольку это требует какого-то действия со стороны пользователя, а onHover. Или onMouse in and mouse out. Ну и так далее, и так далее, и так далее. Так? Это, в общем, это простой случай. Теперь возьмем что-нибудь вроде ahref. Что можно сделать в данном случае? Можно, кто там рекламировал вот этот подход? Что можно сделать? Что именно? Это да, но это уже не будет влиять на нас, это будет влиять на следующий сайт. На нас это как бы не очень сильно будет влиять. Можно сделать что-то другое. Можно сделать, существует такое понятие JavaScript URLs, то есть можно сказать JavaScript, двоеточие, совершенно верно, и после этого команда. Так, закрыть, закрыть и так далее. Безусловно, поэтому я и рекламировал onHover и onMouseOver. Или onload, правильно? Вместо того, чтобы делать onHover, сделай onload. И это, пожалуй, будет работать еще лучше. Это, пожалуй, только два примера, которые показывают, что в принципе существует масса всяких возможностей вставить маленькие кусочки скрипта в данные, которые поставляются, значит, в это приложение. И фильтровать их правильно, на самом деле, очень-очень сложно. Поэтому у вас, в общем-то, в данном случае два пути. Первый путь, который я бы рекомендовал, это не возиться вот с этим делом. Тем более, скорее всего, я подразумеваю, что тут не совсем профессиональные программисты этим занимаются. Скорее всего, это такие студенты-любители. И, скорее всего, это дело полно дыр. Я практически в этом уверен. И поискав, наверное, минут 15, я думаю, что пару из них можно найти. Практически вам это гарантирую. Я этого не делал по разным причинам, но серьезно. Вот. Поэтому либо это все нужно запрещать и просто простой текст, то есть это whitelisting, просто ASCII characters, например. Это подход, который наиболее, в общем, надежный, наиболее простой. Либо нужно действительно серьезно связываться со всеми вот этими вещами и возиться с регулярными выражениями, которые вы разрешаете, и пытаться ограничить это дело очень-очень серьезно, что на практике, в общем-то, очень-очень непростой подход.
Ну, whitelist по регулярным выражениям это еще туда-сюда, а вот нормальный разбор.
Что я могу сказать? В принципе, я просто видел столько разнообразных вариантов ошибок в этом в этом, похоже, связанных, так сказать, в связанном пространстве, что, на мой взгляд, сделать это правильно, без большого количества работы, анализа и внимания, очень-очень непросто. Вот. И, например, если посмотреть на вещи типа того, что, скажем, JavaScript Worm, semi-worm в 2006 году, это результат вот именно вот такого вот подхода. Ну, semi-worm, so back in 2006 or 2005, MySpace, right? MySpace had a JavaScript worm that was launched against it, that basically took down a whole bunch of profiles, took down the site. They spent like 2 weeks cleaning the site and so on and so forth. So what was going on there? Basically the same exact thing. They wanted to allow some of these, parameters. They didn't want to say, oh, well, it's just ASCII text and no HTML. They wanted to allow some of this. They got it wrong. Somebody figured out a way to break into it. Somebody found an cross-site scripting vulnerability and then used it to write a worm that basically attacked the site. And that guy actually went to prison, since you asked. They had a lot of troubles basically since then, and it was basically a pretty unpleasant event. But it came out of exactly this. All right, so somebody was asking how prevalent is cross-site scripting, or how prevalent is SQL injection. So here's XSS.com. That primarily focuses on cross-site scripting attacks that exist in large applications out there. So this is, let's see, this is, I guess, like about a month old. This is back in November when I was, capturing this. So, you can find all sorts of things. You can find Adobe products or Adobe sites being vulnerable over here. There's a Harvard site, there's another one, there is some post office site, some, I don't know, it doesn't really matter. India Times, a newspaper, and so on and so forth. Okay? And most of these are cross-site scripting, but also there are some other kinds of vulnerabilities listed here and there. And most of the time when you look at these listings, the majority of these vulnerabilities are going to be cross-site scriptings, although sometimes you'll find a SQL injection too. If you click on one of these links, this is what you'll find. So here's one of them that comes from Adobe, so this particular site. And this is the URL that they used for testing. So over here, you see there are embedded script blocks. So this keywords equals, and then there's the beginning of the script, see? Then there's this alert that they used to just prove that there is a cross-site scripting attack possible. This is the end of the script block, and this is something else. There's another script, I guess, to capture the document, the cookie of the document over here. So that's what's called a repro. They're using this to show, to reproduce the problem. And this is actually a local repro that they're hosting. So this is kind of a, a simplified version of the site that Adobe has that they're hosting locally. And if you go to that, you'll see that basically, this is the alert box that shows that it's possible to perform a cross-site scripting vulnerability against this. The original site probably has images, but in principle, it's similar to this. Okay? And so here's another example that talks about cross-site scripting in the wild, so back to 2006. And this is a cross-site scripting vulnerability in PayPal that leads to identity theft. So basically, let's see. Let's just read this together. So an unknown number of PayPal users have been tricked into giving away social security numbers. And hackers deceive their victims by injecting and running malicious code on the genuine PayPal site by using a technique known as cross-site scripting. So there was a vulnerability in PayPal.com that allowed the attacker to inject text into the site by using maybe document.write, or maybe by saying something like document.getElement by ID .inner text equals something something. And that allowed them to insert some sort of form into the site that they used for phishing to collect user credentials. Yeah? Does this make sense? So this is the power of cross-site scripting for you in a pretty bad situation. Okay. Yeah, and I think I basically just described it. Oh, actually here. So number 2 is that injected code redirected PayPal visitors page warning users that the account has been compromised. And then there's a phishing site that prompted them for their sensitive data. So that's a slightly different way to do this, but they could have injected some text into the website itself. Okay? And so here's more information about this if you're interested. So, all right, so let's talk about the consequences one more time. So we talked about cookie theft, that this is one problem again. But in addition to that, there is also injecting code into the running application. And then another possibility is injecting a keylogger, right? So how would that work? How would you build a keylogger using this?
Well, only within the current page.
Right. Only within the current page. It's generally difficult to make it reach across to the next page, but within the current page, you can do quite a lot, right? So if you have Gmail, like we have in one of those examples over here, are vulnerable, so how would this keylogger work?
Well, it's JavaScript that listens for, just registers to be notified about each key press.
Yep. So you can say something like body that add listener, what is it? On key up or key down or something, and then you can have your own handler that basically collects this data, buffers it up, and then sends it off. That's how you create a keylogger in JavaScript, and there are actual libraries for doing that too. So it's actually very easy. Okay. So as far as cross-site scripting defenses, I'm not going to talk about that too much. I mean, a very basic defense is to write correct code, which is great advice to us all, but it's very difficult to do. I mean, at the core of the issue, well, there are several fundamental problems. I mean, one of them is to figure out how input propagates through the application and to make sure it does not flow to the output unfiltered, right? So you have input sources, right? So you have these sources over here, and then you have sinks, which is the different ways in which the application sends its information out. So you want to make sure that there is no flow goes from a source to a sink that's not filtered. In the middle over here, you want to have some sort of a sanitizer. Right? So this is your very basic problem as far as development is concerned. It turns out to be really quite difficult for large applications, because if you have a large applications that has hundreds and thousands of files, how do you know that if you have a particular piece of data, do you know whether it's been filtered? How do you know that has it been filtered properly? What kind of sanitizer has been applied to it? What if you apply a sanitizer twice? Is it the same result? Is it safe to apply a sanitizer twice? What if the sanitizer is incorrect, actually? What if they forgot to, blacklist something, or if they're not whitelisting things correctly? So there are many, many questions that sort of come out of this fairly basic problem. And there are, I don't know, about 30 or 40 papers that I've probably read in the last 5 years alone about these, about how to deal with cross-site scripting attacks. So there are reasonable solutions and there are strategies when it comes to development, and there are approaches in static analysis and runtime analysis that I probably don't have enough time to talk about. But at the same time, it remains a relatively difficult problem, and it's not one that's solved, unlike SQL injection, where you just use prepare statements and you're actually probably fine. Okay. So there are simple solutions that exist. I don't know. I don't think I want to talk about that. All right. So let's talk about sort of cross-site scripting a little bit more. If you're really interested in this, there's a book that came out a couple of years ago called Cross-site Scripting Attacks. There's an entire book that's like this thick that talks about cross-site scripting only. Nothing else. They talk about 3 kinds of cross-site scripting. So the kind I was talking about is called reflective or cross-site scripting type 1. When there's some input that goes to the output without being filtered. Then there's also client-side cross-site scripting. What is that? Does anybody know what client-side cross-site scripting might be? So this one is server-side, right? So there's some data that goes into the server and then comes back. What is client-side cross-site scripting? So you have a piece of code that basically, so you have some data that goes, say, into eval. So you say eval s within JavaScript on the client. So what is this s? Where does that come from? So what if you get this s? You say var s is equal to document, I don't know, forms or something like that, 0, and then some argument over here. Get, what is it? I don't know. Get value or something like that, or something called name. This thing over here is provided by the user. It's entirely controlled by the user and goes into this. So the flow is entirely on the client, but the flow can be untrusted because you entirely on the client within JavaScript have untrusted data flowing to this eval command. So this can create fairly arbitrary execution, and as such, it's something that you want to prevent, and this is what's known as client-side cross-site scripting. So it's not touching the server at all. The flow is entirely on the client, but this is kind of a bad flow. Does this make sense? So when you have applications that have a lot of client-side code, like say Gmail, then you have to worry about these possibilities as well. Right? So what if you have document.write that, where the parameter is potentially controlled by the user? What if you have other things as well? What if you have a loop where the loop variable is controlled by the user? They could make it so that the loop will run, forever, for instance, right? Or for a very long time. So you have to be concerned with all of these possibilities on the client too. And then there's persistent, which is basically you can have a kind of cross-site scripting that basically persists over multiple requests. So there is something that it makes, so maybe your database or some backend database that your application talks to already has somehow, a vulnerability that essentially persists over multiple requests. That's how JavaScript worms propagate. Okay? So that's a different kind of cross-site scripting vulnerability that's generally more difficult to create, but is also a problem. Anyway, if you're interested in more, here's this book. I think parts of it are available online. You can go and look it up. I think Google Books has it or something like that. I forget. All right. So here's the comparison I want to draw. So basically, if you think about other kinds of vulnerabilities, so we have buffer overruns, and there's a whole variety of different buffer overrun types. So we have stack-based buffer overruns, we have return to libc, we have heap-based buffer overruns, we have heap spraying attacks, and how do we deal with that? Well, one approach to preventing, preventing buffer overruns is to use memory-safe languages like, say, Java. But also you have to use pretty careful programming. If you don't use Java, you use C and C, C++. And some of these memory-safe languages don't always help. And then to find buffer overruns, you can use static analysis tools, you can use runtime prevention tools, and so on and so forth. But buffer overruns are relatively complicated, are relatively difficult to avoid, although in recent years they've been becoming less and less frequent because of some of these protections I talked about in the beginning, like ASLR and DEP and X. And then we have the other kind of vulnerability, which is format string vulnerabilities, and these are much, much simpler, right? So generally speaking, these are very easy to avoid, and if you use proper APIs, if you don't use unsafe string APIs, then generally you're not going to run into these. And also simple static analysis tools help. Now, cross-site scripting is very much similar to buffer overruns. There are different kinds of cross-site scripting. It requires careful programming. Static analysis tools help, but not entirely. And there are, like I said, at least these 3 different kinds, or maybe even 4, whatever, of cross-site scripting that exists out there. And SQL injection, again, is somewhat similar to format string vulnerabilities. It's relatively easy to avoid if you use good APIs, and then simple static analysis tools generally help. Okay? So this is the parallel I want to draw here between buffer overruns and cross-site scripting and format string vulnerabilities and SQL injection. So how are we doing on time? We have about, 30 minutes, 20 minutes? Где-то 20-25 минут. Я просто не хочу особенно опаздывать, потому что время ограничено. Okay, so introduction to browser security. So far we've been talking about what happens primarily on the server side, within the application. So let's talk about what happens in the browser. And again, I want to draw this parallel between what happens in this case, the operating system and the web browser. So at the level of the operating system, we have system calls, we have processes that run in the operating system, and we also have various resources like file handles and then individual files and sockets and other types of operating system resources. Now, within the browser, the situation is somewhat different. So we have the DOM, the document object model, which is how HTML documents are represented and updated within the browser. We have this notion of frames and iframes that are sort of like processes, if you will, but not entirely. And we also have some resources, such as cookies, for instance, that correspond to local user store. And also we have sort of in HTML5, you have other kinds of local user storage as well. So there is some rough parallel between the two, but it's not a very direct parallel. So also within the operating system side, we have this notion of a user that's actually quite prominent. So me logging into a machine and you logging into a machine are very different things. On the website, we don't really have that well developed. So we have different websites acting as principals. So, I don't know, CNN.com and ABC.com will be very different principals, completely disconnected from each other. That's generally how the web is organized. And then on the side of vulnerabilities, as we already talked about, we have buff overflows and maybe dangling pointer exceptions over here. And then we have our format string vulnerabilities. And over here, we have cross-site scripting and SQL injection. So this is a rough analogy between operating system design and operating system vulnerabilities and what happens in the web. So let's talk about JavaScript, which is really, I think, at the core of what's interesting about security when it comes to web browsers. So the first thing to realize is that JavaScript within the web browser runs in a sandbox, right? It's limited in terms of its capabilities. In particular, it has no direct access to the file system. It has no direct access to the network. And that's good. Is that always enough? I mean, there's a question that people ask quite a lot. So as we see from experience, it's not always enough. It's still possible to exploit things using JavaScript. I talked about heap spraying attacks last time. So this is one example where JavaScript can be used to mount powerful attacks against existing applications. And this notion of a sandbox is relatively difficult to maintain fully. So for instance, can you think of an example where you can actually affect the file system, the local file system, using JavaScript in the browser? Да, совершенно верно. То есть это вариант кэширования, да? Вариант записи в локальную систему, который можно инициировать с помощью запросов, которые можно создать в JavaScript. Да? Кэширование или... кэширование, наверное, это более, так сказать, простой или, так сказать, распространенный случай. Ну да, если какие-то есть такие вот... Если есть автоматическая запись, то примерно то же самое, на самом деле, что и кэширование. Okay. All right, so at the core of browser security, we have this thing called the same origin policy. So how many people have heard of the same origin policy? Show of hands? Not very many. Okay, all right. So here's the idea. So code from a particular origin can only access properties of documents and windows from the same origin. Yeah, so we have two sites. We're here, A.com and B.com. So suppose these are frames within a bigger site. So then there will be a bigger site that sort of looks like this. So this is an iframe over here, and this is another iframe over here. So code from A.com generally will not be able to access this data that exists in this window, and the other way around. So this window will not be able to access data that lives over here. This way you can have untrusted frames coexisting within the same window. So this is a very basic version of isolation. So what is this origin? Well, it's kind of like the URL, but there are some exceptions. So basically, let me show you some examples of that. So basically, the same origin policy for the DOM, roughly speaking, is like this. So we have the origin is defined by the scheme, which is usually like HTTP or HTTPS, and then the domain, which is going to be A.com over here, and then the port. And depending on what resources you are dealing with, maybe the path will be included, but maybe it will not be. So we'll see that for cookies, for instance, the situation is slightly different. Generally speaking, the origin will be sometimes the scheme, although it's optional, so you can mix cookies from HTTP and HTTPS, which sometimes is a good idea, sometimes is not. Then the domain, like a.com, as well as the path. So what does it mean? It means that a.com slash, x, y, z is going to be different from a.com, w, y, z, for instance, when it comes to cookies. So these two paths, these two origins will have different cookies or sets of cookies associated with them. But that's not the case for the DOM. For the DOM, they actually treat it the same, because a.com is shared as well as the scheme, presumably. So there are different rules when it comes to different resources that exist in the browser. Во втором случае вообще порт не используется. В первом случае порт используется, у вас, скажем, порт 80 и порт 81, они рассматриваются по-разному, а во втором случае вообще, так сказать, это дело отбрасывается. Отчасти исторические причины, отчасти как бы просто вот так, что называется, в голову пришло, как мы увидим. Совершенно верно. Например?
Например, как быть, если мы доступаемся не по доменному имени, а по IP-адресу? Как быть, если у нас какой-то портал, который работает с ложными доменными именами? Какие должны быть правила при удлинении, укорочении этих самых путей?
Да.
Огромное количество вопросов.
Да, совершенно верно.
Между HTTP и HTTPS, при скачивании, скажем, чего-нибудь по FTP,
Абсолютно. Совершенно, в общем, совершенно это так. То есть, на самом деле, возникает практически сразу масса вопросов, на которые очевидных и простых решений часто и нету. Вот. Сейчас я просто хочу закончить вот дискуссию про cookies, и после этого я вернусь к вашим вопросам. Okay, so what happens in this case? So actually the same origin policy does not apply to scripts that are loaded from a web page. So scripts are special, as well as images actually, but let's ignore images. Let's think about scripts. So it's possible to have a page where you are basically loading code from a different place. You can have this URL over here, you can just say source, example.com, script, some script.js. That's it. No restrictions apply to this kind of stuff. And basically the idea is that these scripts will be essentially inline to the page and they'll run with the full permissions of the page. They'll do everything a local piece of script, inline piece of script could do. So the idea behind this is that we can basically do library imports, right? This is the idea of programmable web. You can go and take a library from Google and take a library from Facebook and then mix them up, and that's going to be that. Is this always a good idea? Or why is this not always a good idea? Let's put it this way. Например? Ну а что еще более простое? Совершенно верно. Библиотекам, в общем-то, с одной стороны, как бы хотелось бы доверять, но при этом, в общем-то, почему, собственно, мы должны это делать? Ну, в принципе, да, но часто такого рода библиотеки пишутся либо в open source, либо как бы каким-то маленьким производителям, которым, в общем, не очень понятно, насколько можно доверять. И, в общем, проблема не совсем даже такая, которая происходит в in the desktop space. Проблема следующая. Проблема в том, что когда вы разрабатываете это приложение, библиотека является, так скажем, определенные версии, предположим, да? И все работает замечательно, вы тестируете, и все работает по-прежнему. После этого они решают, там, скажем, через неделю все это дело поменять. То есть, возможно, это приводит к тому, что ваше приложение ломается, потому что старые API, которые там существовали до этого, перестают существовать. Возможно, это приводит к тому, что функциональность меняется. Возможно, это приводит к тому, что возникают дополнительные уязвимости, которые возникают либо по их вине, потому что они сделали там какую-то ошибку, либо намеренно, так сказать, просто встроенные уязвимости, которые они по собственной злобе туда и встроили. Все эти совершенно как бы возможности совершенно существуют.
К счастью, в зрелых библиотеках есть механизм контроля версий, и там все это регулировано.
Безусловно, в зрелых библиотеках ситуация существенно лучше, это правда. То есть библиотеки, которые вы получаете, скажем, я не знаю, с Google CDN или Microsoft CDN, что-то такое, как правило, такого рода проблемы, ну, если не полностью устранены, по крайней мере, вероятность их несколько ниже. Да? Но при этом теоретически такая возможность существует. Okay, so dumb SOP. Alright, so more about these cookies. So basically, as I was showing over here, x.com/a does not see cookies from x.com/b. And actually, this is not really a security measure at all. Because on the within the DOM, these two things can interact. So within the DOM, we can actually go to a different frame and get access to its cookie like this. Right? So we just access the frame and then get access to its cookie, and that will be that. The reason this is done is because of our performance, actually. This is done for efficiency. So x.com/a will only get cookies from that particular path, but will not get all these other cookies that are associated with v.com, because the reason is that you can really have a lot of these cookies with different portions of the application. You really don't want to send tons and tons of cookies, because that really slows things down. So many of these are historical reasons and come from a combination of security concerns and performance concerns. And as you were saying just now, actually, here's another hole. So what happens if you have a site like facebook.com, but you also have this other site, chat.facebook.com? And so the goal is to actually have them, the goal of a Facebook developer is to have them actually connect to each other. You don't want them to be isolated, despite the fact that the domains are actually different. This has .dot, this has chat. So there's actually a trick. You can basically say within this guy, you can say document.domain is equals facebook.com, and also say that within this other one, and then they'll basically match. And how does this work? Basically, there's this notion of whether the domain has been set, and if the domain has been set, that there are slightly different same origin rules that apply. So this becomes a complete mess, basically, but it makes this kind of case work out fine for the developer. So as I was saying, as actually you were saying just now, this situation, very quickly becomes very complicated. There is a book that came out back in October. This used to be known as the Google Security Handbook. This is a book now that's this thick that talks about many, many of these rules. There are probably dozens of pages that talk about these topics alone. They compare things as they are developed in different browsers. And as we'll see on the next slide, there are subtle differences across the browsers as well. But they talk about things like, when it comes to the same origin policy alone, because they talk about other topics also. They talk about how DOM access is, when it's allowed, when it's not, what happens if you have XML HTTP request, cookies, Flash, Java, Google Gears, and so forth. Gears? Local storage. Local storage. То есть перед тем, как был стандарт в HTML5, была такая настройка, или, я уж не знаю, расширение, которое называлось Google Gears, которое позволяло сохранять информацию локально в дополнение к cookies. Да, но Google Gears, в общем-то, было разработано лучше, и в результате этого стало частью стандарта. Flash как-то был довольно хилый в этом направлении. На данный момент это уже есть, но у них не было, так сказать, своей инициативы в этом направлении, сколько я знаю. То есть Google в этом плане только доминировал. Но сейчас, опять же, это часть стандарта, так же, как, скажем, и вот это вот тоже часть стандарта. Это раньше было как бы разрозненно, в некий момент эти вещи стандартизируются, обычно занимает процесс 4-5 лет, скажем. So, all right, so let's talk about this one, HTML, HTTP request, just to pick one. So this is the foundation of Ajax-style programming. This is typically how you do things. You create one of these requests, then you say open to access data, or to call out to create a call out there on the web. Then you issue this request, and then when the request comes back, you can go and read the response. This is very simple. But the question is, what kind of request can you create? Can you go and create a request to a third-party server without restricting the origin at all? And there are different rules that apply here. So here's a comparison of the different browsers that exist out there and the capabilities they provide. So this is IE6, IE7, IE8, Firefox 2, Firefox 3, Safari, Opera, Chrome, Android browser. And you can see that basically there is almost, if you look at all of these guys, there's very little consistency, right? There is a little bit of internal consistency. Like if you look at IE, they try to do things somewhat consistent. But if you look at, say, Android versus Opera, well, there's very little. They'll differ in some subtle ways. Как правило, они стараются держать вещи такими же, то есть, как правило, они не хотят это дело ломать. Но опять же, это довольно, в общем, так сказать, очень частные случаи, в общем-то. Вот смотрите, значит, у вас есть что это. May local HTML access unrelated files via local requests, right? So you can create a request that will try to open files on the file system. And the question is, should that be allowed, or is that a bad idea? And so actually, for instance, here, the answer is no, but in the Firefox 2, the answer was yes. And in Firefox 3, they changed it to no. What's going on there? Well, I don't know. And then, can local documents, HTML documents, access sites on the internet? And so IE says yes, and then Firefox says no, Safari says no, and then everybody else says no. So why is that? Well, nobody knows. But there are basically, the more you dig into this, the more subtle these differences become, and that's why there is this book that talks about all these nasty details. So bottom line is that I think simple use cases have been standardized and work well across the different browsers, but then there are subtle differences that still exist. All right, so 2 more minutes. So one other thing I want to talk about is this content security policy that Firefox proposed that basically, actually let me skip this, I don't think I have the time for this. Let me talk about this HTML5 sandbox. So there are mechanisms out there now that have become part of HTML5, the new HTML standard, that allow untrusted code inclusion, but also allow the developer to limit the capabilities of the code they include from a third-party site. And so here's an example of that. So you include some untrusted HTML document like this, maybe from a different domain. And then you can sandbox it by saying, allow scripts, allow scripts and allow forms. These are the capabilities you are giving to this untrusted code. And there are a few others that are also supported by the sandbox tag over here. But by default, none of these things are enabled. So if you don't supply any of these sandbox parameters, then the code will not run any JavaScript. It will not allow any of these forms. It will not be able to navigate away or any of those other things. You have to essentially whitelist these capabilities. You have to opt in. You have to say that you want to support this stuff. And so here's a site that actually demonstrates these kinds of things. So basically, if you have untrusted content that might bring in JavaScript, that content might actually steal cookies, and that's an example of that. And then if you basically include it, but say don't say allow script, then basically that will not be possible, that sort of thing. So here's another one that basically says over here, sandbox form submissions is allowed, and then this can lead to potential phishing problems if you have an ad that you don't trust, for instance, on the site like this. It can try to phish for your login credentials. And so here's another example of page redirection. So you can have an iframe that will try to take your top-level frame to a different page. But again, if you don't give these capabilities, then these things will be blocked. Okay? And then that's that. So this is now part of the standard. It allows to do these things relatively easily. And that's probably a good thing. And again, just like with most of these things, I mean, this was a proposal that somebody put forward. I think Firefox had one proposal, Chrome had another proposal, and then IE had something else. There were these endless discussions and committees that went on for a couple of years, and then something emerged that actually supports probably the, the minimum of what they proposed, the lowest common denominator, essentially, which is not really that much, but maybe in the future this will be extended. I don't think so. I'm not sure what this MS has to do with anything. I really don't understand this. Yeah, this is weird. But basically this is about disallowing pop-ups, right? Or allowing pop-ups in this case. Все, на самом деле, это все, что у меня есть. Мы, в общем, как раз уложились в 1,5 часа.